Today's notes are going to talk about reflections, both vertically and horizontally. So I'm going to begin with a square root function, just because I can see reflections in both ways very easily with a square root function. So I always begin with 0, 0, 1, 1, and the square root of 4 is 2. That's simple. So now what I'm going to do is I'm going to put a negative outside that root x, and let's just pretend that we forget what happens as a result of this. We can always make a table. So I know if I put in 0, I'll get 0 out. That's easy to graph. If I put 1 in for x, I actually get -1 as my answer. I decided to go with 3 because I'm going to run out of numbers to pick from. So I decided to jump to 3. No biggie. It gets you about -1.7. I can do the square root of 4. When I apply the negative, I get -2. And if I do the square root of 5, I'm going to get roughly like -2.2-ish. Okay, so more than enough data to help me make a decent sized graph. So we're going to plot our points, 1, -1, 3, -2-ish, close to -2, 4, -2 exactly, and 5, about -2.2-ish. And then I'll connect them. All right. So if you predicted that this was going to reflect vertically, you are correct. And more importantly, it's symmetric about the x-axis, meaning the x-axis is like the halfway guy between our new graph and its previous graph, its reflection. Okay, with horizontals, we're going to again start with the square root of x. So 0, 0, 1, 1, 4, 2. And we're going to connect. I'm going to do the square root of -x, and that one gets kids a lot because I hear a lot of, well, I thought you couldn't put negative numbers inside the root. Well, -x doesn't have to be a negative number. X can change. So like if I put 0 in, -0 is just 0. I can do the square root of 0. If I want to put -1 in for x, then the opposite of -1 is +1. So I'll end up doing square root of +1, which is fine. So if you have a negative x, you just need to substitute a negative number in for x because those negatives become a positive. So I'll get like positive 1.73-ish for the -3. -4 will end up getting me +2. And -5 will end up getting me +2.24. And then I'm going to plot my ordered pairs, 0, 0, -1, 1, and so on. And you can see they do make the shape of a square root function, but this time it switched over horizontally. So instead of just saying, oh, it reflected horizontally, you actually would be a little bit more specific and say, oh, it's reflected across the y-axis because that's like the halfway point between the previous graph and this graph. So if I give you a picture of a graph and I ask you to describe it, the following order is what you want to use. So if you see any reflections, you want to state those right away. If you see any vertical shrinks or stretches, you want to state those right away as well. Now, you can switch those two. So if you describe a stretch first and then a reflection, you're not changing the picture that I'm visualizing. So those are interchangeable. But your translations, your shifts left, right, up, and down, that has to come last. Otherwise, you actually are describing a different graph to me. So we'll follow 2 simple rules because you will be asked to write a rule for reflection, for example. So if I want you to reflect across the the x-axis, you're going to multiply everything in the problem by -1. And if I want you to reflect across the y-axis, so side to side, you're basically going to substitute -x in for x. So wherever you see an x, change it to a -x. I put a little warning here because this really screws up kids. Once you reflect horizontally, all right, the rules that you would imagine for horizontal shifts are reversed, and you'll see that come up in an example problem. So just keep that on the back radar that if you have to flip horizontally, then you also have to reverse your horizontal shifting rules. So in my next video, I'm not sure how long this one is, but my next video, I'll go through each of these separately.